Okay, here we're going to put everything together that we talked about with our asymptotes and try to graph these functions. So when you do that, we're going to use a graphing calculator, but we are also going to just do this by stating the vertical asymptotes, the vertical or horizontal asymptotes, and any slant asymptotes or oblique asymptotes. So first, let's factor everything. That was a common thing we had to do. So this would be x plus 1 and x minus 1. And nothing cancels, which is fine. That's good. So our vertical asymptotes are x is equal to -1 and 1. They come from the bottom of the fraction that does not cancel. And let's go ahead and put those on our graph. We'll use a dashed line to show that. They're not part of the graph or the function, but we do want to represent them on the graph. Our horizontal asymptote, we can look at the degree. So the degree on bottom is bigger, and so that means the horizontal asymptote is y equals 0. The degree on bottom is 2, the degree on top is 1. And so let's put this here. If we want to talk about domain, we can. Domain is everything except x can't be -1 and 1. And so let's go from -infinity to -1. And we'll join that with -1 to 1. And then we'll join that from 1 to infinity. And then the graph, we can do this, there's a few different ways to do this. The old school way would be to just take some test points, find the y-intercept, plug in 0, pick some points from the, each side to figure out, like, is the graph up here, down here, how does it behave? But because, we live in a time of some great technology, let's go ahead and put that to use for us and look at the graph. And so here we have this graph, 4x squared over x squared plus 1. And you can see, the asymptotes are there, or you can kind of see where they are. If we wanted to, type one in, we won't do both of them, but you could do this. So we'll do both of them. You can see how the lines approach those but never cross them. And then y equals 0, you can see how that line or the graph approaches in this case, it only crosses in the middle, not on either side. But for my purpose, what I think is, like, we're just sketching these. We're really more interested in analyzing the behavior. So for our sketch, we're just going to say, okay, this graph is going to, in the left, it's going to be down here. And it's going to look something like this. The right, if you want to get like the intercept, that's a pretty good thing to have. But it's going to look like this. And then in the middle, rather, and then the right's going to look something like this. So that's kind of good enough for our sketch. Oh, you can't see that. I'm on the wrong screen. Let's try that again. So our sketch, just something like this. It doesn't have to be like a perfect sketch. You can see I even have a bad curve there. But try not to cross asymptotes if you're not supposed to cross asymptotes. That's a good rule to follow. Okay, and hopefully you paused and tried that one on your own. But if not, try these next two on your own. Go ahead and pause the video and give them a shot. We'll start by factoring. We can factor out a 2 here if you want, but nothing cancels. So if you see that, there's really no need to. But it might help you a little bit. Our vertical asymptote happens at x is equal to -1. Our horizontal asymptote occurs, you look at the degree, and they're exactly the same. And so we do 2 over 1 for our horizontal asymptote, or just 2. And there's no holes. We could talk about domain if we want. Our domain just can't include -1s. That'd be -infinity to -1, and then union with -1 to infinity. That's how we just skip over a number in interval notation. And let's put this stuff on the graph. Kind of drop the ball there. X equals -1 is here. and then y equals 2 is here. And then you could plug in, if you plug in 0, it's pretty easy in this case. You could plug in 0 if you want real quick and just get 8. And so you think, well, there's a point. And then you could probably even guess the graph looks like that. But let's go to our calculator too to confirm. Let's see. Find that. So let's pull up the other one. So and our guess was right. You can see the y-intercept. This one has an x-intercept. If you wanted to find that, you could. It's a pretty easy one to find. So let's go ahead and just use those points for our graph. So we have some form of accuracy. Let me switch back to my other view here. And so this graph looks something like this, and this graph looks something like this. Once again, we're getting close to the asymptotes, but we're not touching them, and we're not super worried about how accurate our sketch is, because it is just a sketch. Just make sure those asymptotes are in the right spot. Okay, now number 3, pause the video and try this one if you haven't already. This is already factored, and you notice how this guy cancels, this x plus 4. So my vertical asymptotes are at x is equal to 3 and x is equal to negative 3. Let's list those together. And I'm going to have a hole at x is equal to negative 4. And we'll look at that in a minute here on our graph. And then my horizontal asymptote, we have a degree of 1 on top and 2 on bottom, or 2 on top, 3 on bottom. Look at after it's canceled. So 1 on top and 2 on bottom. And so I have a horizontal asymptote of y equals 0 because the degree on bottom is bigger. And then let's see, we have this hole over here. We don't know where this is exactly yet. So if you want to put the hole on the graph, you could plug in negative 4 here. But it's also, you could look at the table on your calculator to help you, because I guess it won't calculate that. It'll say undefined. But let's look at what our graph looks like. So negative 4, we have a hole, and you can see on here, when you get right to it, it will show that you have this undefined area here. If you look on like one side or the other, you can say it's about, just above negative 1. Not quite to negative 1. If you look at the y values on one side or the other. If you want to plug it in, you can. So let's go ahead and do that. F of negative 4. So we have negative 4 minus 2 over negative 4 minus 3 times negative 4 plus 3, which would be, what would that be? Negative 6. You got a negative 7 times a negative 1. So it's 6 over 7, and it's negative. So the whole is like negative 6/7, which is, somewhere right in here. And I'm not too concerned with how, I did it again. Bummer land. Sorry, guys. I'm not too concerned with how accurate like your hole is, just that your graph kind of goes through it, and it just represent it with the circle on the graph. And so let's look at the graph again. We can kind of see the shape of it. You might look and see, if you want to zoom in on them, you can see if it crosses the asymptote. Here it doesn't look like it does. It stays below. There it just crosses at that x-intercept of 2, 0. So let's get that on the graph. So 2, 0. And then this guy looks like this. It goes through this hole. This comes down, comes through this point, looks something like this. and this looks like this. Okay, and then our domain, we didn't write that. Let's go ahead and put that on the bottom here. It's kind of a long one. We got to skip the whole and the vertical asymptote. So it goes from negative infinity to -4. It's from -4 to -3. From -3 to +3. And then from +3 to infinity. That's everywhere the function exists. Okay, good luck with this stuff. Enjoy graphing rational functions.